A 10 microcoulomb charge is placed at the origin. The second negative 6 microcoulomb charge is placed 1 meter to the right of the first one. And the third 6 microcoulomb charge is placed 1 meter above the first charge. So that's 1 meter, and here is 1 meter. What is the electric field at this point? X equals to 1 and Y equals to 1. So we have Q1, Q2, Q3. Q1 is gonna be this way. Q3 is gonna be this way. Actually E1, E3 is gonna be this way, and E2 is gonna be toward negative, is gonna be this way. So let's find out each of them first. E2 equals to KQ divided by R squared. 8.99 times 10 to the power of 9. That's Coulomb's constant. Q is 6 times 10 to the power of negative 6 divided by 1 squared. So that will give me 8.99 times 10 to the power of 9 times 6 times 10 to the power of negative 6. That will give me 53940 Newton per Coulomb, or 5.39 times 10 to the power of 4 Newton per Coulomb. That's E2. E1, the distance here is going to be square root of 1 squared plus 1 squared. That's going to be root 2 based on the Pythagorean theorem. So E1 is going to be KQ divided by R squared. 8.99 times 10 to the power of 9 times 10 times 10 to the power of negative 6 divided by square root of 2 to the power of 2. That's going to give me 4.49 times 10 to the power of 4 Newton per Coulomb. Now E3, the distance is the same as this guy and the charge is going to be the same but it's positive. So E3 and E2 is going to be equal in terms of magnitude. So 5.39 times 10 to the power of 4. Then I can say E1, I need to make it as E1x and E1y. What is going to be the theta? Theta is going to be here, same as here. That's opposite divided by adjacent is going to be 1 because these two are equal. So it means that the theta is 1 and theta is 45 because tan 45 is 1. So the theta is 45. So E1x equals to E1 times cosine 45 and E1y is going to be E1 times sine 45. And we know cosine 45 and sine 45, both of them are the same. So we don't need to calculate it twice. 4.49 times 10 to the power of 4 times cosine 45. That will be 31749. 3.17 times 10 to the power of 4 Newton per Coulomb. Same thing here. Now we need to find out E net. E1y and E2 are two different directions. Which one is bigger? E1y is 3.17 and E2 is 5.39. So E2 is greater. So EY net is going to be E2 minus E1y which is going to be 5.39 times 10 to the power 4 minus 3.14 times 10 to the power 4. That is going to give me 2.22 times 10 to the power 4 Newton per Coulomb. EX net is going to be, both of these two is going to be in the same direction. So it's going to be E3 plus E1x. E3 is 5.39 times 10 to the power 4 plus 3.17 E1x times 10 to the power 4. That's going to be 8.56 times 10 to the power 4 Newton per Coulomb. Now if we want to find out the E net in total, it's going to be EX squared plus EY squared, 2.22 times 10 to the power 4 squared, plus 8.56 times 10 to the power 4 squared. That's going to be 8.84 times 10 to the power 4 Newton per Coulomb. And in order to, and we already found the theta as well, theta is going to be 45. We don't need to calculate it again.